Okay, you guys, Ms. Shapiro's here, and we're going to talk briefly about irrigation, both what it is, how we currently do it, and the advantages and disadvantages of that. So, the most important thing to know is that irrigation is when we water plants that are growing on a farm. So, we're watering our crops. Most of our fresh water, and remember that fresh water is only about 3% of all of the water that's on the earth. I'm sorry, 70% of our fresh water is used for irrigation. So, if I asked you to make a claim about the withdrawals, for the year 2010, you could use this map and you might say that the United States used or withdrew more water than Western Europe. You might say that China and India and the United States withdrew the most water for agriculture. You might see that parts of Central and I'm trying to think, never eat shredded, like West or Southwest Africa drew the least amount of agricultural water. And that's just because they don't have the technology to do irrigation. They rely on rainwater. So irrigation, it can come when we irrigate crops, the water comes from two places. In some places, like in California or in the Arkansas Valley, where we are in Colorado, that water comes from snow melt runoff. So it snows in the mountains, and then during the spring, that snow melts, and the water begins to flow into the waterways. And so that we pump that water out and out of our rivers, and we put it through a ditch or an irrigation system, and then we water our crops there. We may supplement some of our water with groundwater that we pump up from an aquifer, but most of the water in California, parts of the breadbasket, the Arkansas Valley, where I am in Colorado, comes from snow melt runoff. Other places like in Arkansas and Nebraska Kansas and Nebraska may pump from an aquifer. So the largest aquifer in North America is the Ogallala Aquifer. It's one of the largest in the world. And what we see is that it is being pumped, or with water is being withdrawn at a rate faster than it's recharging or it's filling back up. In fact, you can see the water levels change from 1980 to 1995. This problem has only gotten worse. We see that there's a significant decline in parts of the panhandle of Texas, Arkansas, and then into New Mexico. I'm kind of here in southeast Colorado, so we don't really draw from the Ogallala Aquifer, although it's somewhat close to us. But we see that it's heavily withdrawn for the breadbasket of the United States in parts of Kansas and Oklahoma, the panhandle of Texas. And so that's a major concern. A lot of it is not really being impacted. We see that gray area in which the water is recharging just as fast as we withdraw it. But some areas are that dark red, and we're very concerned about that because water is going to be a hot commodity, and we want to ensure that we don't use too much of it to prevent future use, that tragedy of the commons. Water is not really a public utility anymore now. We buy water rights or mineral rights, and water is sometimes included in that. Although it's pretty common to have state lawsuits against one another. For example, Colorado and Kansas are always locked in water lawsuits as they argue over water rights. So irrigation sometimes, like we were talking about, comes from pumping water out of an aquifer. So when we pump water out of an aquifer, you see that upconing starts to occur. Sometimes there is salt dissolved in that aquifer water, and it's not salty like the ocean, but it does have small amounts of salt. We see it as paleosaline groundwater, and we pump that up, and then we use it to water our crops. And so what happens is that water is used to irrigate crops, and the water is either taken up by the plants or it evaporates, and the salts that were dissolved were left behind. When they accumulate, we call that salinization. And so sometimes farmers will flush their water in an effort to try to get rid of those salts, and we might call that waterlogging. Waterlogging also occurs when the water table increases, it moves up, and it begins to saturate the roots of the plants. And plants respire, they breathe. Specifically the roots, because they're not green, right? They're not doing photosynthesis. So they take in oxygen, they are aerobic. And so when we surround them with water, there's not enough oxygen around them. And essentially the plant roots begin to drown. And when that happens, we call that waterlogging. It may be purposeful, like you may put the water on in an effort to fix salinization, or it may be occurring because of a flood or improper drainage in your fields. Okay, so let's talk about how we actually do irrigation. So there's four types of irrigation. The first one is furrow irrigation. This is the cheapest. It's the easiest to do. It's been around the longest. Most farmers already have the technology for this. And so what happens is you have some type of big long pipeline or a ditch, and then water is pumped through that ditch, and then you use either holes in the pipeline, or sometimes farmers have these big tubes. And they use the tubes to pump the water from the ditch into the furrows or into the holes between the rows of crops. And so this is cheap. It's easy to do. So for example, my uncle is a farmer and he goes and he sets water every night, and it takes him maybe 30 minutes to set all this up. And he leaves it there for however long he wants the water to be on the field. And then he goes and picks up all the pipes and he just repeats the process. What we do know is this leaves a lot of the water open to runoff and evaporation. In fact, this is the least efficient method of irrigation. It's the cheapest, it's the easiest to do, but 30% of that water is lost. The second type is flood irrigation, and this is when we do pretty much that. We flood the fields with water. This can recharge aquifers depending on drainage, and we only lose about 20% of the water to evaporation, but not all crops like this. In fact, most of your vegetable crops don't really like this, and it can lead to waterlogging, where the plants kind of lose that ability to have oxygen, and therefore their roots begin to drown. The next kind of irrigation is what we call spray irrigation. And so this is, you can see it in the picture, and it's essentially using a large scale sprinkler. Sometimes they do have sprinklers like you might see in your yard. And this is pretty expensive to install, but you may use soil sensors. They're going to monitor the soil for soil moisture, computers, GPS, GIS, soil monitor. Oh, I already said that. Soil monitoring sensors. They may use computerized weather reports, and just to kind of track and see how much moisture is available. Only 25% of the water is lost here with spray irrigation. However, it requires machines and fossil fuels. So usually these spray irrigations are motorized, and so they're going to use fossil fuels in order to run. Companies usually have spray irrigation, or big farmers. Your small local organic farmer or your small town farmer is probably not going to have spray irrigation. And then the last one is drip irrigation. So drip irrigation is the most efficient. Only about 5% of the water is lost, but it's really, really time intensive. You got to set up each one of those black tubes. And so what happens is there's a little hole in the tube. And so when you flood, or when you push the water through the tube, then it comes out the holes and it waters the plants. It's very labor intensive to set up, and it's very expensive. It's not really useful in large scale farming. It may be appropriate for small vegetable gardens or flower gardens, but we don't often see it in big commercial farms unless they have a lot of money to put forth. The water source that you use also has to be super clean. If it has any kind of sediment or tree roots or tree debris in it, it'll plug up those holes, and that makes it not very efficient. So with that, that's all I have. I hope this was helpful. You do have a little sort activity after this. So let me know if you have any questions.